Welcome back, physics fans. Here we go with average speed lesson number 2 in physics 11. We did just speed and velocity yesterday, and now we're going to do average speed and average velocity. Go, resume. So, what about different sections of a trip at different constant velocities? Right now, we've been doing just like one part when we were going at one velocity, but what about multiple constant velocities? Do we take an average? For instance, if you drive at 10 kilometers an hour, then you drive at 30 kilometers an hour, is your average speed 20? No. Why isn't it? Okay, what happens if I drive for 10 kilometers an hour for 1 minute and then 30 kilometers an hour for 4 hours? My average is not 20 because I did this a lot longer than this one. Okay, similarly, if we had some of the students that got 60% on the test and the rest of you got 90% on the test, does that mean the class average was 75? No. The average is the average score per student. So if we received a mark of 60, if two of them received 60 and 28 received a mark of 90, it'll be actually much higher than 75, much closer to 90, and it's actually around 88%. So what do we do here? Okay, so if the average score is per student, what is the average speed respect to? Well, average speed, as we know, speed is distance over time. So it's the distance with respect to time. Time is in the denominator. Time is in the denominator, and it's the with respect to time. So the answer is average speed is the average distance per hour. And the only surefire way to calculate this, and I've had lots of people argue, but this is it, and I nice big red rounded things. To get the average speed, you get the total distance divided by the total time. Well, I reduced the formula to this, and I even reduced the formula to this, V equals D over T. Hey, that's our formula again, right? Okay, except we have to understand that if this is the average, AVG, then these have to be the total. So if the average is the total. Okay, so let's go do a question number 1. Okay, just practicing this out. We're still using the same formula, V equals D over T. Okay, so example number 1, and there's 2 parts to the entire trip. Mr. Currell drives at 50 kilometers an hour for 2 hours and then drives at 70 kilometers an hour for 8 hours. What's the average speed? Okay, 50 for 2 and 70 for 8. If you didn't know the times, the average between 50 and 70 is 60, but this is not going to be 60 because I did this one 4 times longer. Okay, so I kind of organize my stuff in charts just so you can see it through and it will help you. So part 1, I did 50 kilometers an hour and a distance of, oh, I don't know, but I got the time of 2 hours. And what else is given? In part 2, I went 70 kilometers an hour and a time of 8 hours. So the formula here is distance is velocity times time. So I got 50 times 2, and I get 100 here. So I drove 100 kilometers here. Okay, and I'm going to highlight that yellow because that's one of my first things that I calculated. And then over here, I'll do it in red. I get 70 times 8, and I get 560. So this was 560 kilometers. Okay, and now there's a section here called the average or total. Okay, and I'm going to do a big block right here because we can never go across there, but here we can go plus equals, plus equals. It makes sense though. If I do 100 kilometers, then 560 kilometers, then I will actually have gone 600 260 kilometers. And if I went 2 hours there and 8 hours here, then I went 10 hours. Okay, I'm going to highlight these green because I just added them. Okay, and also when you're looking at your notes, you might not know how you did this. So I kind of also like putting numbers up in the corners. This is the first thing I calculated. This is the second thing I calculated. That's the third thing I calculated. And that's the fourth thing I calculated. Just the order. Because when you look at it and the whole thing is all filled out, you go, I don't know where to start. This helps when reviewing. You don't need it. I'm just putting it there right now just so you understand that when you review. So now I want the average velocity. So the V average is equal to D total over the time total. And that's going to be equal to 660 all over 10. And it is kilometers per hour. And this will just be 66 kilometers per hour. Those people that are a little bit OCD will have to fill out the table and put 66 there, but I'm just going to write down 66 over here. Done. Okay. Go ahead and try example number 2 right now. It is a little bit different, but the same process. And then come on back. And if you're on the internet right now, pause this. You have 3 seconds. 3 seconds to pause after I stop speaking here, and then I'll unpause it, and you'll see all the answers just pop in. Okay. 3, 2, 1, pause. Okay. And here's the answers. Okay, 50 kilometers an hour for 4 hours is 200 kilometers. 120 kilometers an hour for a distance of 45 took you a time of 0.375 hours. I add up 4 hours in that, I get 4.375 hours. Oh, I have highlighter on. Hours. And this is 245 kilometers. So V average is the D average divided by T average. No, D total. Bad, Mr. Curl. D total all over T total. Okay, and that's going to be 245 kilometers divided by 4.375 hours. So I divide this by 4.375. Oops, not divide that. I have to type in 245 divided by 4.375. And I get a nice number that I set up, 56. Okay, and here's the big tip, okay, and the big arguments that I'll get into all the time with students that are trying to learn this, that are especially mathematicians. We never use the math average to calculate the average velocity. Never. We never go 50 plus 120, which is 170, and divide it by 2. And 170 divided by 2 is 85. It's not 56, but the answer is 56. We can't go 50 plus 70, which is 120 divided by 2, and get 60. It's 66. Why is it? Why is it? Here's the quick lesson. Because when we take the average, it's per the time. So if you spent the same amount of time in each section, then the answer is the mathematical average. So if you spent 2 hours at 50 and then 2 hours at 70, then the average is 60. But because we spent different amounts of time, then it's actually called a weighted average, not just a regular average. Okay? This This can be calculated a weird way. Just take a look at this and you'll understand it. Maybe if you're an advanced mathematician, here we go. I did this for 2 hours and I did this for 8 hours. So I did this speed 4 times longer. So if I take 50 plus 70 plus 70 plus 70 plus 70, and then take the average because I did it 4 times longer. So if I take 50 plus 71, 2, 3, 4, and then divide it by my 5, I get to 66. It's a weighted average. It has to be, so understand that if you go the same distances, you can't do it. It has to be the same times. Okay? And there's a couple questions here that you can try. And what's different about number 3? I'll just show it to you and then you can work on it. This is interesting. Mr. Currell drives at 45 kilometers an hour for 3 hours. 45 kilometers an hour for 3 hours. Okay. And then drives 2 more hours. And he averages for the entire trip 55 kilometers an hour. So the average is 55 kilometers per hour. Uh-oh. And they're asking what was the speed. So I'll highlight in blue. That's what they want. That's the answer that we were trying to get from this question. What is the speed in that second part? Okay, so previously we've been doing questions like A plus B is equal to, no, sorry, yeah, okay, A plus B is equal to an unknown. Now we're doing A plus an unknown equals C. How do you do this? In algebra, we have to subtract. So that's what we're going to have to use in here, subtraction somewhere, okay? I'll give you that shot to try it out. I'll pop in the video right back so you have the answer, okay? You have 3 seconds to pause. 3, 2, 1. Okay, here's the halfway point. Okay, we were able to calculate 135 kilometers for the first section. And for the total trip, we found out that it's 5 hours. And because of this formula, D equals V times T, which also works for the average and totals. So D is 275 because it equals 55 times 5. Then what's the next step? It's the subtraction I was hinting at. So keep on going, please. 3, 2, 1. Yes, the 275 minus the 135 is 140. And if you drove 140 kilometers in 2 hours, then your speed in section 2 is going to be 140 kilometers over 2 hours, which is 70. How many were able to get 70? Sweet. Okay. There's one more thing to learn here, and it is helping you a little bit get lazy, but it's also helping you when you don't have units that you know. Okay? For instance, take a look. All the speeds are in kilometers per hour. All the distances are in kilometers. All the times are in hours. As long as all the units are the same, we don't even have to put the units in because they cancel out. And that'll help on weird questions like, here's the question. A race car driver drives 3 laps at 200 kilometers an hour and then one more lap at 250 kilometers an hour. What was his average speed? I know you're packing up, but just watch this. So you set out that you have V, D, and T. For this first section, you have a speed of 200 kilometers an hour, and you have 1 lap. No, you have 3 laps. Okay, and the second section, you have 250 kilometers an hour, and you have 1 lap. Okay, so what I'm asking for is on the average, give me the average speed. So the question goes, well, how far is a lap? Because if this is in kilometers per hour, don't I need this in kilometers? No, you don't. you could leave these in laps and it'll still work through. As long as these speeds are in the same unit, then it'll work through, which is absolutely weird. Does that mean the lap could be 1 meter or 10,000 kilometers and it'll be the same answer? Yes. So the time here is just going to be equal to distance over velocity. So that's going to be 200 over, no, 3 over 200. Sorry, my bad. 3 over 200. And the time here is just going to be 1 over 250. So the total time will be just the addition of these two fractions. The total distance will be 4. So the average, ABG, is just going to be the total distance 4 over whatever that fraction is equal to. And you got it. Okay? Thank you very much for watching and enjoy. Have a good day.